The United States is losing the chip war to China, and the story of how that happened is one most people have never been told. Washington launched the most aggressive technology sanctions in modern history, spending hundreds of billions of dollars in allied investment to build a wall around the world's most advanced semiconductors. To put that in perspective, that is more money than the entire annual economic output of New Zealand. You heard that right. But instead of stopping China, those sanctions may have just handed it the greatest industrial motivation in the history of modern technology. Here is what is really happening and why it changes everything. That brings us to the foundation of this entire war, the technology that makes it worth fighting in the first place. The technology that runs the world. Imagine every screen going dark. Not just your phone, every screen, everywhere. Now imagine every aircraft in the sky losing the systems that keep it stable. Every hospital monitor going silent. Every financial transaction on Earth frozen. Not because of a war. Not because of a natural disaster. But because one category of product, smaller than your thumbnail, stopped being made. That is the world without semiconductors. And once you understand that, you understand why two of the most powerful nations on Earth are tearing at each other's throats over them. Chips are not a tech product. They are not a gadget accessory. They are the nervous system of modern civilization, and everything that runs civilization depends on them. The fighter jet that protects a nation's airspace. The power grid that keeps the lights on across an entire continent. The artificial intelligence systems being trained right now that will shape medicine, warfare, finance, and communication for the next 50 years. Every single one of them runs on semiconductors. But here is what most people do not know, and this is where it gets important. Not all chips are the same. The chip inside your microwave and the chip powering a cutting-edge AI system are not remotely comparable. Think of it like the difference between a bicycle and a supersonic jet. Both have wheels. Both move, but they exist in completely different universes of capability. At the very top of that hierarchy sit the most advanced semiconductors on Earth, chips so complex, so difficult to manufacture, and so expensive to develop that only a handful of companies and a handful of countries can produce them. These are the chips that train AI models. These are the chips that power next-generation weapon systems. These are the chips that whoever controls them controls the future. And for decades, that control belonged almost entirely to the United States and its allies. But this was just the beginning of the story, because the real question is not who built that dominance. The real question is how America built a system so powerful, and then watched another nation start dismantling it piece by piece. To understand how China is winning, you first have to understand exactly what America built and why it believed that empire was untouchable. How America built an empire out of silicon. For most of the 20th century, if you wanted to build something that ran on electricity and intelligence, you needed America. Not just American chips, American everything. The United States did not stumble into semiconductor dominance by accident. It engineered it deliberately, systematically, and over the course of decades. American companies designed the chip architectures that the entire world adopted as standard. American software firms built the electronic design automation tools, the EDA tools, that every chip engineer on Earth uses to draw the blueprints for a new semiconductor. Without those tools, you cannot design a modern chip. And for a long time, every single company that made those tools was American. But the dominance did not stop at design. America cultivated a global supply chain where every critical node ran through either American hands or the hands of its closest allies. Taiwan, a small island with an outsized role in history, became the home of TSMC, the most advanced chip manufacturer on Earth, producing semiconductors that no other company could match. South Korea became the world's memory chip powerhouse, with Samsung and SK Hynix supplying the storage components that every device on Earth depends on. And in a quiet Dutch city called Veldhoven, a company called ASML built the single most critical manufacturing tool in the entire semiconductor industry, a machine so specialized, so irreplaceable, that the whole global supply chain flows through it. On paper, this looked like an unbreakable system. America at the center, trusted allies at every critical node, and the rest of the world depended on the network to function. But here is what nobody was saying out loud, and this is the part that matters. That system was not a fortress. It was a spider web. extraordinarily strong when every thread holds, catastrophically vulnerable the moment something pulls at the wrong point. America's dominance was real, but it was built on the assumption that its allies would always hold the line and that its rivals would always need to play by its rules. For decades, China did exactly that. It bought chips, it licensed technology, it built factories that assembled products designed by others. It operated inside the American-led system because it had no other choice. But China was watching, and China was learning. And the moment it decided it had learned enough, everything changed. Because what happened next was not a gradual shift. It was a declaration of war dressed up in the language of export controls. Washington draws the line. October 7th, 2022. Remember that date. Because on that day, the United States government did something it had never done before. It did not just sanction a company, or target a specific product, or slap a tariff on an imported good. It attempted to freeze an entire nation's technological future in place. With a single sweeping set of export controls, Washington went after China's access to advanced AI chips, the software tools used to design semiconductors, and the manufacturing equipment needed to build them. All at once, in one move. To understand what that actually meant, you have to understand the three walls Washington tried to build simultaneously. The first wall, chips. The United States blocked companies like Nvidia from selling their most advanced AI processors to Chinese buyers. These were not ordinary chips. These were the engines behind the most powerful AI systems on Earth, the same chips used to train the models that are now reshaping every industry on the planet. Cutting China off from them meant cutting China off from the computational horsepower needed to compete at the AI frontier. The second wall, software. Every chip that has ever been designed was designed using EDA tools. Electronic design automation software is the invisible foundation of the entire semiconductor industry. Without it, you cannot draw a chip. You cannot simulate it. You cannot verify it works before you spend hundreds of millions of dollars manufacturing it. And because the companies that make the most powerful EDA tools are American, Washington could simply turn off the tap. The third wall, equipment. This was the most ambitious move of all. Advanced chip manufacturing requires extraordinarily specialized machines. Machines that etch, deposit, and pattern silicon at scales measured in billionths of a meter. Washington moved to block the export of those machines to China, cutting off the physical tools needed to build next-generation semiconductors on Chinese soil. In the rooms where these decisions were made, the confidence was palpable. Officials believed they had found the three pressure points that, squeezed simultaneously, would bring China's semiconductor ambitions to a halt. No chips to power its AI, no software to design new ones, no equipment to manufacture them. The logic was clean. The execution looked decisive. But Washington made one assumption that would come back to haunt it. It assumed that China would accept the ceiling. It assumed that being locked out of the system meant being locked out of the future. That a nation cut off from the tools of progress would simply slow down, fall behind, and eventually be forced to negotiate from a position of weakness. What happened instead was the opposite of weakness, and it was coming faster than anyone in Washington was willing to publicly admit. Because China did not slow down. China opened its wallet, and what it spent next would rewrite the rules of the entire industry. The one machine China cannot buy. There is a company most people have never heard of. It does not make smartphones. It does not run social media platforms. It does not sell anything you have ever held in your hand. But without it, the entire modern world, every advanced chip powering every AI system, every cutting-edge military processor, every next-generation device, stops being made. That company is ASML, and it operates out of a city in the Netherlands called Veldhoven that most people could not find on a map. Here is what ASML does. It builds extreme ultraviolet lithography machines, EUV machines, and it is the only company on Earth that can. No competitor, no alternative, no substitute. Just one company, in one country, making the one tool that the entire advanced semiconductor industry cannot function without. To manufacture the world's most advanced chips, you need to etch circuit patterns onto silicon at scales so impossibly small that the human eye cannot begin to perceive them. We are talking about features measured in just a few nanometers, a nanometer being 1/1000th of a meter. To put that in perspective, a single strand of human hair is roughly 100,000 nanometers wide. EUV machines are etching patterns thousands of times smaller than that. You heard that right. To do that, ASML's machines generate a specific type of light, extreme ultraviolet light, with a wavelength of just 13.5 nanometers. That light is produced by firing powerful lasers at tiny droplets of molten tin, 50,000 times per second, generating plasma that releases EUV radiation. The whole system fits inside a machine the size of a double-decker bus, costs close to $400 million per unit, and contains over 100,000 individual components supplied by thousands of companies across the globe. It is arguably the most complex manufacturing machine ever built by human hands. And China cannot buy one. Under intense pressure from the United States, the Dutch government blocked ASML from shipping its most advanced EUV systems to Chinese firms. Then, as Washington tightened its grip further, even the older generation of machines, the deep ultraviolet lithography systems that China had been using to push its manufacturing capabilities forward, faced new restrictions. Layer by layer, the most critical tool in semiconductor manufacturing was being pulled out of China's reach. Washington understood exactly what it was doing. EUV is not one component of advanced chip manufacturing. It is the gatekeeper. Without it, you cannot manufacture chips at the leading edge. You cannot build the processors that power frontier AI. You cannot compete at the top of the semiconductor stack. Locking China out of ASML was not just a sanction. It was an attempt to put a hard ceiling on China's technological ceiling permanently. This was supposed to be the kill shot. The one move so surgical, so precise, and so impossible to work around that it would freeze China's ambitions in place for a generation. But something nobody in Washington had fully prepared for was already stirring inside China's borders. And it was being funded at a scale that had never been seen before in the history of the technology industry. Because when China realized it could not buy the machine that makes the future, it decided to build one itself. China answers with the largest bet in tech history. When the sanctions landed, the world watched to see how Beijing would react. Some analysts expected negotiation. Some expected retaliation through trade. Some expected a period of quiet regrouping China, absorbing the blow, recalibrating, and eventually finding a way back into the American-led system through back channels and workarounds. What happened instead was none of those things. Beijing did not flinch. It did not negotiate. It did not ask for a seat back at the table. Instead, it did something that sent a shockwave through every boardroom and government office tracking. The chip war. It opened the largest industrial checkbook in the history of the technology sector and wrote a number so large it barely seemed real. China committed over $140 billion to domestic semiconductor development. $140 billion. To put that in perspective, that is more than the combined annual revenue of Intel, Qualcomm, and Texas Instruments. You heard that right. And that was just the opening move. State-backed investment funds began pouring capital into every corner of the domestic chip ecosystem simultaneously. New fabrication plants broke ground across the country, in Shanghai, in Shenzhen, in Wuhan, in cities most people outside China have never heard of. Government subsidies flooded into domestic equipment makers that had previously operated in the shadows of the global industry, suddenly finding themselves with virtually unlimited resources and a national mandate to deliver. Chip design firms that had struggled to compete on the global stage were handed the funding, the talent pipelines, and the political backing to accelerate at a pace the private sector alone could never have sustained. But the money was only part of the story, because what Beijing did next went far deeper than writing checks. China restructured its universities around semiconductor research. It launched nationwide programs to train a new generation of chip engineers, tens of thousands of them, specifically to feed the domestic industry it was building. It passed directives requiring Chinese technology companies to prioritize domestically made chips wherever possible, creating an instant guaranteed market for an industry that was still finding its feet. It tightened its grip on the rare earth materials that feed the global semiconductor supply chain materials that China already dominates in production. signaling clearly that if Washington wanted to play the sanctions game, Beijing had its own leverage to deploy. This was not a policy response. This was a national mobilization, the kind of concentrated, top-down industrial drive that free market economies simply cannot replicate. A billion-person economy reorganizing itself around a single technological objective with the full weight of state power behind it. And here is what made it truly dangerous for Washington. China was not just trying to catch up to where the global chip industry was today. It was trying to leapfrog the dependency entirely to build a version of the semiconductor supply chain that existed completely within its own borders, answerable to no foreign government, vulnerable to no foreign sanction, and stoppable by no export control Washington could ever design. For the first time in the history of this industry, a nation was attempting to rebuild the entire global semiconductor ecosystem from scratch inside its own borders. And the rest of the world was only beginning to grasp how far along that effort already was. But throwing money at a problem and actually solving it are two very different things. And what China built next, layer by layer, would force the world to completely reassess what it thought was possible. Building the ecosystem, layer by layer. China did not just write checks and hope for the best. It attacked the semiconductor problem, like a general planning a multi-front war hitting every single layer of what experts call the stack, with surgical precision and overwhelming resources. Start with chip design. For years, even China's most advanced processors had been based on architectures originally developed in American research labs. ARM designs from the UK, x86 standards from Intel, GPU layouts from Nvidia. But now, Chinese firms like Huawei's HiSilicon and startups backed by state funds began pouring resources into creating their own blueprints, architectures optimized specifically for the Chinese market, the Chinese software ecosystem, and Chinese strategic needs. These were not copycat designs. They were purpose-built alternatives designed to break the intellectual property stranglehold America had enjoyed for decades. Then came manufacturing equipment, the hardest nut to crack. China had spent years importing the full suite of tools needed to build chips, etchers from Japan, deposition systems from the United States, metrology equipment from Germany. Sanctions cut most of that off. So Beijing turned its domestic equipment makers, companies like Naura Technology and AMEC, into national champions overnight. These firms received billions in funding to develop domestic alternatives, their own plasma etching systems, their own chemical vapor deposition chambers, their own wafer inspection tools. Were they as good as the global leaders? Not yet, but they worked. And with every new factory line they equipped, China's dependence on foreign machines dropped another percentage point. EDA software was the next battlefield. Every chip ever designed, from the processor in your phone to the supercomputer chips training AI models, was laid out using electronic design automation tools. The market is dominated by three American companies, Synopsys, Cadence, and Mentor Graphics. Their software is so advanced, so deeply embedded in the industry, that chip designers call it the only game in town. China responded by funding open-source alternatives and proprietary domestic tools like Empyrean Technologies' Suites programs good enough to design real commercial chips, even if they trailed the bleeding edge by a generation. Do not forget materials. China already controlled over 80% of the world's rare earth refining capacity, the elements that go into the magnets, lasers, and polishing compounds that make chip manufacturing possible. Now it was doubling down, securing domestic supplies of photoresists, silicon wafers, and high-purity gases to feed its growing fab network. Each individual piece was behind the global frontier. Lithography machines still could not match ASML. EDA tools still lacked the polish of Synopsys. Domestic etchers still needed another year of refinement. But here is what made analysts wake up at night: the cumulative effect. China was not patching one hole in the dam. It was building an entirely new riverbed, one that flowed only through Chinese territory, answerable to no foreign government. Layer by layer, tool by tool, material by material, a parallel semiconductor universe was taking shape. And the most shocking proof of that universe's existence was about to land in the palm of every smartphone user on Earth. Because what happened next was not a lab breakthrough or a government announcement. It was a consumer product that forced Washington to completely rewrite its calculus. The Huawei moment that shocked Washington. It started with a smartphone. Not a lab prototype, not a military chip, a phone you could buy at a store. Huawei quietly launched the Mate 60 series, and inside was something that made semiconductor analysts around the world drop what they were doing. A 7-nanometer Kirin chip, manufactured domestically by SMIC, made without the most advanced ASML equipment, made without the unrestricted access to EDA software, made in direct defiance of what the export controls were explicitly designed to prevent. The chip was not at the absolute frontier. TSMC was already shipping at 3 nanometers, but that missed the point entirely. China was not supposed to be able to do this, period. SMIC had squeezed advanced performance out of older deep ultraviolet lithography machines. They had innovated around software restrictions. They had built domestic tools good enough to get the job done. The chip worked. It powered a flagship phone, and it shipped by the millions. Washington was stunned. Classified briefings were called. Analysts pored over teardowns. The question was not just how China did it. The question was what else they had already accomplished that nobody knew about. Then came the most devastating realization of all. If China could produce a 7-nanometer chip under full sanctions, what could they do with 3 more years of unrestricted domestic investment? This was no longer theoretical. The gap was closing. And it was closing faster than the public narrative admitted. But here is the question nobody in Washington wanted to face head-on. Were the sanctions actually working, or were they doing the exact opposite of what they were intended to do? Are the controls working, or are they backfiring? Let us cut through the noise and look at the evidence. The sanctions have teeth. Nvidia's most advanced AI chips, the H100 series that power the world's largest AI models, remain locked out of China. Without EUV machines, China cannot manufacture chips at the 3-nanometer node at scale. The gap between TSMC's leading edge and SMIC's best output is real, measurable, and for now holding. China is slowed. It has not stopped. But here is the part Washington did not see coming, and this is what keeps analysts up at night. By cutting China off from the global supply chain, the United States handed Beijing a unified national mission semiconductor independence, backed by unlimited funding, unlimited political will, and a billion-person economy laser-focused on solving the problem. Every blocked ASML shipment created a new domestic lithography program. Every restricted EDA license created a new Chinese software team. Every missing Nvidia chip created a new domestic AI accelerator project. The sanctions did not extinguish ambition. They weaponized it. Washington thought it was building a wall. Instead, it built a mirror, forcing China to look at its own reflection and decide it liked what it saw. A fully independent chip ecosystem, no foreign choke points, no export-controlled vulnerabilities, a supply chain that answered to Beijing alone. Here is America's fatal flaw. It controls design and software, but Taiwan controls manufacturing at scale. The export controls protect leverage without building capacity. While China constructs new fabs at a frantic pace, America debates subsidies. Blocking tools buys time, but time alone does not win races. America plays defense. China plays offense. And that asymmetry is why the United States is losing the chip war. Because every sanction designed to contain China simply taught it how to build what no sanction can ever touch.